Okay, so today now we will see the numericals on the friction, ladder friction. Okay. So I think we have written the problem. Numerical is given to you. What was the numerical?
A ladder is placed against a vertical wall as shown in figure.
Okay, the weight, how much weight or the point where the person is standing, what distance?
Weight is 800 Newton and
Ah,
distance is 2.7 meter.
okay, so 2.7 meter and 800, that problem we are dealing with. So uh, we have not drawn the diagram, I think. So now we will draw the diagram first. The given diagram I will draw now. This is the vertical wall. Then this is the surface. And we will draw the ladder. So this is the ladder. Now here at this bottom, this is the point A. This is your point B. So this angle is given at 60 degree. Then what they have told us, the length of the ladder, it is given in the diagram. Okay, so some data is given in the diagram also. So you have to check the diagram. So the total length of the ladder is given, this total length, and this total length of ladder is 4 meter. Then a man which is standing at a distance of 2.7 meter. So this is 800 and 2.7 meter. So this distance from this point up to here, it is 2.7 meter. This is 2.7 meter. And then the self weight. What is the self weight of this ladder? The self weight of the ladder is also given as, just 1 minute. Okay, so now what is the what is the self weight? Self weight of the ladder, it is 200 Newton, it is given in the numerical. So the self weight, it will act from the center, and this self weight, it is given as 200 Newton. Okay, so it will act at the center. So this distance will be, if total is 4, then it is 2. Always say, remember that self weight is always acting through the CG. Okay, so from CG we should show the self weight. So now afterwards we will draw the free body diagram. And what does this free body diagram says now? Suppose this is the horizontal reaction RB. Here it is the horizontal reaction RB. Then vertical reaction will be FB. That will be also here at point B. So here is FB. This is FB. And the reaction, this is RB. Okay, frictional force FB and a normal reaction is RB. Then at point A,
Background voice खूप येतोय.
Just 1 minute, I will tell to reduce the noise. Just 1 minute.
Yes, sir.
Now are you able to hear me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay. So now at point A, here again the normal reaction is RA. Normal reaction is RA. And here frictional force will be in this direction. This is FA. Now I think you are clear with the direction of the frictional force. Okay. It is always in the opposite direction to the motion. So this much of data is given to us. And what they have asked in the numerical, they have asked you to determine the coefficient of friction between ladder and floor. So we have to calculate the coefficient of friction between this ladder and this floor. So we have already known the coefficient of friction between wall and ladder. Wall and ladder is known to us. So we have to find out this one. So I will say this here. The value is, I can say it is mu B. And what is the value? Whatever notation you want to use, you can use. It is 0.2. Okay. And here the coefficient of friction at point near point A is mu A, and that we need to calculate. What is the coefficient of friction? So there is no change in our methodology. Okay. Like the previous problem, how we have calculated the things, that is force P and all that thing. Same way we are going to apply over here to solve this numerical. So first of all, what we will do, we will take the moment of all the forces about this point A. So we will take the moment of all the forces about this point A, then summation M about A is equal to 0. So the clockwise forces are positive and anti-clockwise forces are negative. Okay, so clockwise force is positive, anti-clockwise negative. Then this FA is passing through point A, so its moment is 0. Then RA is also passing through point A, so its moment is 0. This 200 Newton force. Now for this 200 Newton force, what is the perpendicular distance? This is the perpendicular distance. Force is vertical, so your distance must be horizontal. So this is the perpendicular distance. This angle is 90 degree. So moment is nothing but this force into this perpendicular distance. Now how to calculate this perpendicular distance? Now if you consider this triangle, this is your hypotenuse. 2 meter is hypotenuse. Now if the hypotenuse is 2 meter and this angle is 60 degree, then this distance will be 2 cos 60. It will be 2 cos 60. Yesterday also I have taken it directly. बघा ज्यांना समजलं नसेल त्यांना एकदा सांगतो मी. But from next time I will take it directly. Okay, you should be familiar with these things. This is the simple trigonometry. See, suppose now this is the triangle. This is your triangle. This length is 2 meter. This length is 2 meter. Okay, we want to calculate this. This is x. And this angle is known to us, it is 60 degree. This angle is 90 degree. Here this angle is 90 degree. Okay, so now we want to calculate this x. Now here if I use cos of theta, here if I use cos of 60, so cos of 60 will be how much it is? Adjacent side divided by hypotenuse. So it will be x by 2. So x by 2 is nothing but your cos 60. So now I want the value of x. So my x will be x is equal to 2 cos 60. So x is equal to how much? It is 1 meter. Cos 60 is 0.5. Cos 60 is 0.5. So it is 1 meter. So this is the calculation behind this. So for every triangle, we will do the same calculation. Now, when you are calculating the distance of this 800 Newton, we should take this much of distance. At that time, we have to consider this much of triangle to calculate this distance. Okay, when you are going to take the distance of RB distance means this is the perpendicular distance of RB from point A, from A point. Okay, if you now I will first of all take the force of 200 Newton. So it will be 200 into this hypotenuse is 2 meters, so it is 2 cos 60. 2 cos 60 is the distance. Now it will rotate in clockwise direction. You can see this is the arrow, this is the point. If you rotate it towards the point, it will rotate in clockwise direction. So it is plus. Next is this 800 Newton force. Now if you see this 800 Newton force, what is the distance of this 800 Newton force? Perpendicular distance. Now from this point up to here, 800 Newton, the total distance is 2.7 meter. The distance is 2.7 meter, angle is 60 degree. So this distance will be 2.7 cos 60. Okay. So it is 800 into 2.7 cos of 60. This is also plus. This is also plus, as it will rotate in clockwise direction. It will rotate in clockwise direction. Now RB. Now see carefully. If I extend the line of action of RB, if I extend the line of action of RB like this, then what is the perpendicular distance? So from point A, this is the perpendicular distance of RB. This is the line of action of RB. Okay, so from point A, this is the perpendicular distance because RB is the horizontal force. So its perpendicular distance must be vertical. So this is the RB and this is your perpendicular distance, this much. So this will be this much of distance. Then it will be, now if you consider this total triangle, this angle is 60 degree. If this total is 4, if this total is 4, then this will be, it is 4 sine 60. Okay. It is 4 sine 60 and this will be total 4 cos 60. See, if I draw this triangle, roughly if I draw the triangle now, it is the big triangle. It is like this. Okay. This is the triangle. Suppose now this total is 4 meter and this angle is 60 degree. This angle is 60 degree. Then this will become 4 sine 60. And this is 4 cos 60. You can calculate it. After calculation, you will get the same answer. Okay. This will become 4 cos 60 and this is 4 sine 60. So your RB is situated over here at this point. And your point A is here somewhere. This is your point A. So your distance will be 4 sine 60. So now the further is RB. RB, it is rotating in which direction? Anti-clockwise direction. RB is rotating in anti-clockwise direction. So here minus RB into 4 sine 60. RB into 4 sine 60. Okay. Then this FB force. So this force is FB, which is acting over here, FB. So this distance we need to calculate. This is the horizontal distance. FB force is vertical. This is the line of action of FB. So from this line of action, this is the distance, perpendicular distance. So this distance will be, if this total is 4, here I have calculated, this total distance is 4 cos 60. This total distance is 4 cos 60. And RB is moving upward. So if you rotate the RB about the point A, it will rotate in anti-clockwise direction. So again, this FB is also minus. So I will write here minus FB into 4 cos 60, which is equal to 0. So now here, you know FB, relation between FB and RB. But here I can say FB is equal to, frictional force at B is equal to mu B into RB, which is equal to 0.2 into RB. Now if you put the value, what you will get? It will be plus 200 into 2 cos 60. You do the calculation. Plus 800 into 2.7 cos 60 minus RB will remain as it is, RB into 4 sine 60, and then again minus this FB. Instead of FB now I will put 0.2 RB. So here it is 0.2 RB into 4 cos 60, which is equal to 0. Now there is only one unknown RB. Therefore find out the value of RB. Let me know the answer of RB. What is the answer? Or shall I solve it? Okay, I will solve it with you now. So now see here, 200 into 2 cos 60. So it will be 200 into 2 cos 60. So it is 200. Okay, so this will be 200 as it is, plus here it is 800 into 2.7 cos 60. It is 1080 minus 4 sin 60. 4 sin 60. So it is 3.46. So minus 3.46 RB. Okay. Then again minus, it is 4 cos 60 into 0.2 minus 0.4 RB, which is equal to 0. So if you send RB to that side, it will become plus. So therefore, it is 3.86 RB is equal to 1280. 1280. So 1280 divided by 3.86. Do the calculation. Let me know the answer.
31.60.
331 point
60.
okay 60. So it is 331.60 Newton. This is RB. Now I will apply. Now I can calculate the value of FB. FB is equal to what? FB is equal to, here we have already written 0.2 RB. So put the value. 0.2 into RB is 331.60. So FB is equal to how much?
66.32.
66.32 Newton. So this is the FP. This is the value of FP. Now, see here, if I apply summation Fy equal to 0, apply summation Fy equal to 0, upward plus, downward minus. So now when you apply summation Fy equal to 0, you see RA is moving upward positive, 200 is moving downward negative, 800 is moving downward negative, and FB is moving upward. It is positive. Okay. So that we will write the equation RA plus FB minus 200 minus 800 is equal to 0. Therefore RA plus, what is the value of FB? 66.32. This is minus 1000 is equal to 0. Therefore RA is equal to, calculate now.
$933.68.
933.68.
68.
So this is the value of RA. This is the value of RA. Now we don't know the value of mu. Mu A, that value we don't know. We need to calculate that value. So now what we will do? we will apply summation fx equal to 0. Now I will apply summation fx equal to 0. Towards right plus, towards left minus. So now if I use summation fx equal to 0, now see here, horizontal forces. This fa, it is moving towards right, positive. This rb, moving towards left, it is negative. So only two forces are there. There is no any other force which can contribute to this. So fa minus rb is equal to 0. So your equation will be fa minus rb equal to 0. So therefore fa minus 331, no? 331.60 is equal to 0. Therefore fa is equal to 331.60 Newton. This is the value of fa. Now in the problem they ask us find the value of mu a. So now fa is equal to mu a into ra. So fa is 331.60 is equal to mu as it is into ra. Ra is, what is the value of ra? 933. Therefore mu a is equal to, let me know the value of mu.
0.355.
0.355. This is the value of mu. This is your final answer. This is your final answer. Now check the problem. I will give you 10 seconds. Please see the problem. If you are having any doubt, immediately ask. हाँ.
Slide change करा ना.
Okay. Is there any doubt in this? कोणाला डाऊट आहे का याच्यात?
No, sir.
No. Okay. So we will take the next numerical then. A ladder shown in figure is 6 meter long. 6 meter long and supported by horizontal floor and vertical wall. Full stop. The coefficient of friction between the floor and ladder is 0.25 and between wall and ladder is 0.4. Full stop. The self weight of ladder is 200 Newton. 200 Newton. Comma. The ladder also supports a vertical load of 900 Newton at C. Okay, full stop. Comma, which is at a distance of 1 meter from B. Determine the value of alpha at which ladder may just keep or ladder may just placed without sleep. Okay, so this is the given numerical. Now we will read the numerical. A ladder shown in figure is 6 meter long. So ladder is 6 meter long and supported by a horizontal floor and vertical wall. So it is supported by horizontal floor and vertical wall. The coefficient of friction between the floor and ladder is 0.35 and between the wall and ladder is 0.4. So the coefficient of friction is given between floor and ladder 0.25, between wall and ladder 0.4. Self weight of ladder is 200 Newton. You know that self weight is always acting through the CG. So the self weight, and it is also acting vertically downwards. So the self weight is 200 Newton, it is given. The ladder is also supports a vertical load of 900 Newton. So excess load of 900 Newton is there, which is acting at point C. And this point C is at a distance of 1 meter from point B. So now they have not given us the angle of the ladder, angle of inclination. They told us to determine the value of alpha at which the ladder may just placed without slip. So now if I draw the diagram of this, this is the floor, ladder. So this is your point B. Point A. Now some given data is there in the diagram also. So as they have told us, this is the load of 900 Newton. Then self weight 200 Newton. So total length is 6 meter. This total length, this is 6 meter. Now they told us that this C point is at a distance of 1 meter from B. This is at a distance of 1 meter. Okay. And now the self weight, this is your point C. Now the self weight is of 200 Newton. This is the self weight of 200 Newton. So total is 6 meter. So this self weight will act through the center, that is the CG, and it is, this distance is 3 meter. Okay. This is 3 meter. And this angle, this is alpha. This angle is alpha, which we need to calculate. This is the horizontal reaction. Here it is the vertical reaction at E. This is RA and RB. This is RA. This is RB. Similarly, we can show FB. This is FA. This is FB and this is FA. So now think on this and tell me how to solve this problem now. This mu B, this value is given. This is 0.4, wall and ladder. And here the mu A, this is 0.25. This is the given data in the numerical. Now let me know how to solve this, what we are going to do. Think on the numerical. What you will do, what will be your first step? So while solving the numerical of the staircase, your procedure will be same. Same procedure you should adopt. Here what I will do, I will take the moment of all the forces about A, whatever we are doing earlier. Summation M about A equal to 0. Clockwise forces positive, anti-clockwise forces negative. So again, how it will be now? See, this RA and FA, it will become 0. Now this 200 Newton, the distance of this 200 Newton is this one. So this distance is 3 meter. So this will be 3 cos alpha. This is 3 cos alpha. So 200 into 3 cos alpha, and it will rotate in clockwise direction. So it is 200 into 3 cos alpha. Then this 900 into this much of distance. So how much is this? This much. See, this total is 6 meter. This is 1 meter. So from this point up to here it is 5 meter. This is 5 meter. So this will become 5 cos alpha. So 900 into 5 cos alpha plus. Okay. Now next is, if I extend the line of action of RB, this is the RB. This is the line of action of RB. So what is the perpendicular distance of RB? This is the perpendicular distance from point A. This is the perpendicular distance of RB. This is the perpendicular distance. So now this total is 6. This angle is alpha. So this will become 6 cos alpha. When it is anti-clockwise direction, minus 6 cos alpha into RB. So RB into 6 cos alpha or 6 cos alpha into RB. Is it right? Is it right, or it should be sin alpha?
Sin alpha.
Correct. It is sin alpha, not cos alpha. So your RB will be RB into 6 sin alpha, again minus FB into how much it is? This is, here it is the FB. If this total is 6, then this will be 6 cos alpha. Which is equal to 0. Okay. So if you do some calculation, you will get one equation. So let it be as it is. ठेवायला तोपर्यंत as it is, बघू काय करायचं नंतर ते. Now alpha is also unknown, RB is also unknown, and FB you can calculate now. We know that FB, this is 0.4. So here you can write 0.4 RB. So in this problem you can write 200 into 3, how much? 600 cos alpha plus 9 into 5, 45 cos alpha minus RB into 6 sin alpha minus, here it is 0.4. 0.4 into 6. Here it is 6 now. So 0.4 into 6, 2.4. 2.4. It is RB into 2.4 cos alpha is equal to 0. So let us say that this is our equation number 1. Now apply summation fx equal to 0. Summation fx equal to 0, towards right positive, towards left negative. So if I apply summation fx equal to 0, now you can see here which forces will come in summation fx. Fa will be there, horizontal force, and Rb will be there. All other forces are vertical. So Fa and Rb. So here I will write Fa minus Rb is equal to 0. Okay. So therefore, Fa means what? Here you know that this is 0.25. So here I can write now FB. FB is nothing but it is 0.4 RB because mu is 0.4. And FA is nothing but it is 0.25 RA because mu is 0.25. So here I can write FA is nothing but it is 0.25 RA minus RB is equal to 0. Is equal to 0. Okay. This is your equation number 2. Now if you apply summation Fy equal to 0, Fy equal to 0, then Ra moving upward positive, Fb moving upward positive, 200 is minus, 900 is also minus. So Ra and Fb are positive. Ra plus Fb minus 200 minus 800 is equal to 0. Okay. So Fb is nothing but it is 0.2 Rb.
Sir,
Huh.
minus 900 ना
900 दिलाय का? हाँ 900 correct. मी चुकून 800 लिहिलं. 900 correct. So this is minus 900. Ra plus Fb is equal to 1100. Now put the value of this Fb here. We know that this Fb is equal to 0.4 into Rb. So this value we have to put over there. So if we put that value here in this equation, so Ra plus here it is Fb means 0.4 Rb. So Ra plus 0.4 Rb is equal to 1100. This is your equation number 3. Okay. Now solve equation 2 and 3. Solve equation 2 and 3. So you will get the value of this Ra and Rb. Solve the equation 2 and 3. This is your equation 2, 0.25 Ra plus Rb equal to 0. And here Ra plus 0.4 Rb is equal to 1100. So here from this equation you can write now further. Therefore here you can write Rb is equal to 0.25 Ra. That is what we get from here. Rb is equal to 0.25 Ra. Now put this value of Rb in this equation. So here Ra as it is plus 0.4 into Rb is 0.25 Ra. So put that value 0.25 into Ra. So now do the multiplication 0.4 into 0.25. Let me know the answer quickly. What is the answer? So it is Ra plus this is 25 into 4 into किती झाले 100 1 2 3 0 सोडून पॉइंट येणार ना
0.1
0.1 is equal to 1100. Therefore Ra is equal to किती येते सांगा आता
सर
हा
0.1 RA पाहिजे का
हा बरोबर आहे here it is 0.1 Ra no here Ra चा आहेच की असा so this multiplication is 0.1 Ra for Ra it is as it is and 1100. So now this will become 1 plus 0.1 so it is 1.1.
1000
This is 1.1 Ra is equal to 1100. Therefore Ra is equal to 1. Okay. This is the value of Ra 1000 Newton. Now from the value of Ra you can find out Rb. We know that from equation 2 Rb is equal to 0.25 Ra. So calculate the Rb. From equation 2 Rb is equal to 0.25 into 1000. Therefore, RB is equal to, what is the value?
250.
250 Newton. Now put this value of RB in equation number 1. Now this is our equation 1. So in this equation 1, two unknowns are there, RB and alpha. Now we know the value of RB. So put the value of RB over here. So you will get the value of alpha. Now I will write the equation. It is 600 cos alpha plus 4500 cos alpha minus this RB. Now RB into 6 sin alpha. Now this term RB into 6 sin alpha. RB is 250. So put the value over here, 250. 250 into 6. So it is 250 into 6 is 1500. So this is 1500 sin alpha. Then here RB again 250. So put that value, 250 into 2.4. It is 600. This is 600 cos alpha. This is minus 600 cos alpha is equal to 0. So now here you can see this plus cos alpha and minus cos alpha will get cancelled. So next line what we will get? It is 4500 cos of alpha minus 1500 sin of alpha is equal to 0. Therefore 4500 cos alpha is equal to 1500 sin of alpha. Therefore sin alpha upon cos alpha is equal to 4500 is 4500 divided by 1500. Therefore, what is the answer? Tan alpha
3.
is equal to 3. So alpha is equal to
1.5.
किती आला? Tan inverse 3 how much?
71.56.
71.56. So the value of alpha is 71.56 degree. This is your final answer. Any doubt, any difficulty?
No, sir.
No, sir.
Okay. समजले काय काय केले ते? Problems are simple, but just you need to follow the procedure so that you will get the answer. So this is the numerical. Okay. So now this is, I think these many problems are sufficient for the friction. Now in the friction, we have seen the problems which are related to sphere and related to block. Also some problems we have seen. The blocks are attached with the string, that also we have seen. Okay. Then the two blocks are kept in the cylinder, that also we have seen. After that, in the friction, we have seen the single block which is kept on horizontal plane, which is kept on inclined plane. Then we have seen the two blocks kept on two inclined plane. That type of problem also we have solved. And after that, we have switched over to the ladder friction. In the ladder friction also, we have seen up till now two types of problems which basically ask in the examination if it is offline, that the unknown force P that should be applied at point A, that is the problem number 1. Okay, and now this problem number 3, to calculate the angle. If angle is not given, how to calculate the alpha. So with this, all the variety of this second bit is covered. Now we will move to the next bit in the tomorrow's lecture, and that is the types of supports. In that we will learn types of supports, types of loads, what is beam, and how to solve the numericals on the beam. Okay, that will be our last bit for this unit, unit number 2. Okay. So give the attendance. Just 1 minute. Just 1 minute, I will. Okay. Okay. Roll number 1,
Present.
2,
Present, sir.
3, 4. हाँ. NPTEL केल्यावरती बघावं लागेल 10वा किंवा ओके 12 पिऊयात कुणाला पाठ आहेत तेवढे तोंडपाठ 12 पिऊयात कन्फ्युजन कसलं येते त्यात ओके सो रोल नंबर 1
Present.
2
Present, sir.
3
Present, sir.
4
Present, sir.
5
Present, sir.
6
Present, sir.
7
Present, sir.
8
Present, sir.
9
Present, sir.
10
Present, sir.
11
Present, sir.
12
Present, sir.
13
Present, sir.
14
Present, sir.
15
Present, sir.
16
Present.
17
Present, sir.
18 19
Present.
20
Sir.
21
Present, sir.
22
Present, sir.
23
Present, sir.
24
Present, sir.
25
Present, sir.
26
Present, sir.
27
Present, sir.
28
Present.
29 40 आपलं 30
Present, sir.
31
Present, sir.
32 33
Present, sir.
34
Present, sir.
35
Present, sir.
36
Present, sir.
37
Present, sir.
38
Present, sir.
39 40 41
Present, sir.
42
Present, sir.
43
Present, sir.
44 45 46 47 48
Present.
49 50
Present, sir.
51 52
Present, sir.
53
Present, sir.
51 is present, okay. 53
Present, sir.
54
Present, sir.
55
Present, sir.
56 56 57
Present, sir.
58
Present, sir.
59, 60, 61.
Present, sir.
Okay. So 49 is present. Okay. So absent roll numbers are, once again confirm the roll numbers: 32, 40, 44, 47, 56.
Sir, 40 present.
40 is present. Okay. Then 56 and 59. So 32, 44, 47, 56 and 59 are the absent roll numbers. Okay. So the next part we will take in the next lecture. Okay. We will stop over here today. हा बोला.
ISC सॅम्पल पेपर एक टाका ना ग्रुपवर.
ISC चा का?
ISC साठी हा.
सॅम्पल मीन्स व्हॉट? तुम्हाला क्वेश्चन बँक पाहिजे, काय पाहिजे नेमकं?
स्ट्रक्चर वगैरे कसं असेल काय असेल
फॉर्मॅट कसं आहे त्याचं?
फॉर्मॅट. हा
ठीक आहे. फॉर्मॅट सांगतो तुम्हाला, टाकतो मी ग्रुपवरती.
सर थेअरी पेपर होणार आहे ना म्हणून पाहिजे ते.
हो. तुमचं ऑफलाईन फायनल झालं का?
ऑफलाईन नाही सर, ऑनलाईन
म्हणजे
देऊन द्यायचंय. आम्हाला PDF करून असाइनमेंट सारखं सबमिट करायला सांगितले पवार सरांनी.
बर. ठीक आहे, तुम्हाला मी फॉर्मॅट सांगतो पेपरचा, त्याला काय अडचण नाही. आणि पेपर मध्ये तुमच्या चॅप्टर नंबर 1 आणि चॅप्टर नंबर 2 दोन्ही करायचं बरं का, Unit-1 आणि Unit-2. हा, बोथ द युनिट्स. Unit-2 पण तुमचा संपल्याचा आहे. Unit-2 जेवढं झालेलं, आता शेवटचा बीट चालू होते उद्या Unit-2 चा. ओके. So I will tell you the format today evening or tomorrow morning.
ओके सर.